Okay, Bismillah ar-Rahman ar-Rahim. We'll continue. We'll continue doing this section 3.7. Now we'll do this part. We'll finish. We're done with the volumes. Now we'll do the things related to the Pythagorean theorem. Let us see what will happen. Okay. Let's say an airplane is flying on a flight path. Okay, they call it X. I call this X. I have this. This is X. Okay, they're taken directly over a radar tracking station. We have a radar here. Okay, and this distance is fixed, which is 6 miles. Okay, the distance is decreasing. I have this distance, the distance between the airplane as it's going and the radar station at the rate of 400 kilometers. So I have ds over dt. Since it's decreasing, it should be minus 400. Okay. The units are okay, huh? Miles, everything is miles. Okay, miles per hour. Okay. Now what they want to find the speed of the plane when s equal 10. No, the speed is the absolute value of dx by dt. Okay, so I'll find dx over dt, and then I'll find the absolute value. I need for the Pythagorean theorem, I need s squared is x squared plus 6 squared. Note this one, there is a relative change here. This one is fixed. This one, there is the change. As the airplane is going, there is a change for x and y, so I'll leave it x and s. For this one is fixed, so I'll keep it as a number. It will not be changed. Okay. So now I notice one thing. If s equal 10, then I can get s. I can get x, substitute here. So I have 100 equal x squared plus 36. So that means x squared is 64. That means x equal 8. Okay, so I get x equal 8 when it's equal 10. Now differentiate this equation or this relation with respect to t. I have 2s ds over dt equal 2x dx over dt. I have this. I have this. I got this. So I can find this. Okay, let us plug the numbers. 2 times 10 ds by dt is minus 400 equal 2 times 8 times dx over dt. 2 cancelled. So dx by dt will be what? Minus 400 times 10 over 8. This is over 2. Over 4 is 2. This is 100. Over 2 is 1. This is 50. So I have minus 500. So the speed of the airplane will be absolute value minus 500, which is 500. 500 mile per hour. Mile per hour. Okay. A plane flying horizontally at an altitude of 1 kilometer. The airplane is going. Okay. And the speed 400. Let me call this x. I have dx by dt equal 400. The altitude is 1. This is altitude. Pass it over radar station. Here, the radar station. The distance, this we call it s. So I have s squared equal x squared plus 1 square. What they want? the distance between the plane to the station is increasing when the plane is 2 kilometers away. So I need to find ds over dt when what? When the plane is 2 kilometers away from the station, when s equal to, when s equal to. Okay, I have s square equal x square plus 1 square. That implies 4 equal x square plus 1. That implies x square equal 3. That implies x equals square root of 3. I'm not considering negative because these are distances. Okay, now differentiate and just substitute. So I have 2s ds by dt equal to x dx by dt. I have this. I have this. I have this. I want this. Ah, so we get it. So ds by dt, cancel the 2. It'll be x. X is what? Square of 3. Dx by dt, which is 400, over s, which is 2. That will be 200 square root of 3, which is okay. Yes, this is problem in the book, in the exercises of the book. Okay. Now I have two airplanes. I have one here. Spot two planes at the same altitude, okay, converging on a point as they fly on right angles to each other. One is going in that direction, the other one going in this direction, like in the picture. So they're going to this point. Okay. So let me call this x, call this y, because both are changing, nothing fixed. And also the distance between them is also changing. So all the three, x, y, and s, are changing. Okay, what are the information? One plane is 25 miles from the point, moving at this. Let me say dx by dt is 450. Okay. And is it plus or minus? Since this distance is going in that direction, so the distance as it's going is decreasing. This x is decreasing as we are going. So this would be minus 450. Okay. And this one dy by dt, the same thing. The airplane is going this, so this distance is decreasing. That will be minus 600 miles per hour. Okay. So I want to find first question. They want the change of the rate of the distance between the two planes decreasing. So I want to find ds over dt when x equal what? 2 to 5 and y equal 300. Okay. I want to check how, because I said what is the distance between decreasing. Okay. So I have s square equal x square plus y square. And they have x and y. Since they have x and y, that will make it easier for me to find s. So s square will be 225 square plus 300 square. Do the calculation since it's a very big number. That implies s is 375. Now differentiate this to get what? 2s ds by dt equal to x dx by dt plus 2y dy by dt. Very clear, this two I can cancel it. I have s, I have x, I have dx by dt, I have y, I have dy by dt. So I'll find this. I have everything, just plug it, then you can find everything. So ds by dt will be x dx over dt plus y dy over dt over s, which is 375. If we do the calculation, you will get what? Yeah, I don't like these big numbers. It will be minus 75, minus 750. Mile per hour. That will be the rate of change for S. The question, how much time does the air traffic controller here have to get one of the planes on a different flight path? Since the distance is 375 and the rate of change is this, so to get the time will be S over this, 375 over 750. This is decreasing negative, I don't care about it. So the time will be half an hour. So he has, if you do this, you have half. So he has half an hour. This is part B. Because you have part A and part B. So that you should direct the other airplane to move to another path, or they will hit each other, which is clear. Now we'll come to the ladder problems. Okay, a ladder 5 meter long, rest against a vertical wall. We have a vertical wall, and there is a ladder rest against it. The side of the ladder will not be changed, so this is fixed. This one fixed. If the bottom of the ladder slides away, call this x, call this y. So I have dx by dt equal 1 meter per second. Okay. How fast is the top of the ladder sliding? If move this way, then this ladder will also go this way. So I need to find dy by dt when the bottom of the ladder is 3 meters from the wall. When the bottom of the ladder is 3 meters from the wall, so that when x equals 3. What is the relation to start with? This is Pythagorean theorem. So I have x squared plus y squared equal 25 squared. And since x equals 3, that implies y squared 5 squared equal 25 minus 9, which is 16. So y equal to 4. So now I differentiate this with respect to x, with respect to t. I have 2x dx by dt plus 2y dy by dt equal to 0. Since the ladder is fixed. So I want what's dy by dt. That implies dy by dt will be what? Minus x dx by dt over y. What is x? X is 3. Dx by dt is 1. Y is 4. So it will be minus 3 over 4. It's decreasing because it's very clear this side is decreasing, but this side is increasing. Okay. Another 20 feet long is leaning against the wall. Okay. Same idea. So I'm doing it quickly. This is 20. This is x. This is y. From the wall at the rate of this. So dx over dt equals 3. How fast the top slides down? I want this. Find dy over dx, dy over dt. When? When the top of the ladder is 8 feet from the ground. So when y equal 8. Okay, I need to find this and y equal 8. So I have x squared plus y squared equal 20 squared. Which is 400. So we do the calculations. I have x squared equal 400 minus 64, and that is 336. So x square root 336, which is what? 336 is, yeah, if we check it, yeah, let me check it quickly. Divide by 16. Yeah, I know it. So it's 21. So this is will be 4 root 21. Yeah, that will be 4 root 21. Okay. So now I differentiate this. I have 2x dx by dt plus 2y dy by dt equal to 0. So I need dy by dt, which is minus x dx by dt over y. And that will be minus 4 root 21. Dx by dt is 3. And y is 8. So that will give me what? Minus 3 root 21 over 8. That will be the answer. A ladder 10 meters long against the wall. Okay, we have a ladder. We have a wall. We have a ladder. This is then fixed. The base of the ladder is pulled away from the wall at a rate of 3 over 2. Pulled away from the wall, yeah. So I have dx by dt equal 2 over 3. Okay. What happened here? X and y. He's not talking about, he doesn't want dy over dt. He notice there is a triangle. You want the change, because if this one is moving and this one is moving, the area of the triangle will be changing. So he wants the rate of change of the area of the triangle. So I need to find, and what is A, by the way? It's the base times the height times half. So it will be half xy. I want to find the rate of change of A. Find dA by dt when the base of the ladder is 6 meters from the wall. So when x equals 6. This is what I want. So to find dy by dt, now I will consider x is changing and y changing. So dA by dt will be half product, so that x or dx, I have y dx by dt plus x dy by dt. So I need x, I need y, I need dx by dt, I need dy by dt. This is given. This is given. The rest I don't know. So I have the relation x squared plus y squared equal 100. 10 squared, which is 100. From this, I plug x, I get y equal 8. So I get y. The remaining is dy over dt. Also from the relation, if we differentiate, I get what? 2x dx over dt plus 2y dy by dt equal to 0. So dy by dt will be minus x dx over dt over y. And that, if you do the calculation, will be what? Will be x is 6, dx by dt is 2 over 3, and y is 8. So that will give me what? Okay. Uh, 12 over 4. Yeah. X over dt is 2 over 3, so okay. That will give me minus half. What is it? This is 2, this is 1, so it's minus half. Yes. So dA by dt will be half. Now I get this one. Well, let's plug the numbers then. Y, be careful. 8 dx by dt, which is 2 over 3. X is 6 times minus 1 over 2. That will give me what? Half 16 over 3 minus 3. And that will give me half 16 minus 9 over 3, which is 7 over 6, which is this. Yeah, calculation. I think it's okay. This is actually in the book, but the numbers are different. The same idea, but it has part A, part B, part C. We'll do these 3 parts. About the ladder, I think this is will end the idea of these ladder problems. What we have in this one, we have a wall, we have a ladder 25 feet, and a ladder 25 feet is leaning against the wall of house. The base of the ladder is pulled away from the wall at the rate of this. So I have dx by dt equal this x equal this y. Dx by dt equal to what they want. A, how fast is the top? So he wants dy by dt. You want this. How fast is the top ladder moving down the wall when the base is 7 feet? And I will not take 7 feet, I'll take 15 because the calculation will be easier when y equal 15. When x equal 15, sorry. Yeah, from the wall. The base is okay, when x equal 15. This will make the calculation easier. I think comparable to the other numbers. The numbers are big, but I think that will be easier. So what is the relation? I have x squared plus y squared equal 25 square, which is 625. So y squared will be 625 minus 15 square, which is 225, which is 400. So y equal 20. Okay, if I get y, I get everything now. So to find dy over dt, just differentiate this. 2x dx over dt, not dt, plus 2y dy by dt equal to 0. So dy by dt equal minus x dx over dt over y. And that is, yeah, be careful with the number. This is minus 15. Dx by dt is 2 over 20. And that give us what? Minus 3 over 2. Part B. I want now, he said, consider the triangle and find the rate of change of the area. But I will take x equal 15 because I already did the calculation from that. So you need to find the area. The area which is half xy. So the rate of change of the area will be half y dx over dt plus x dy over dt. And that give me half. Let me select the numbers. Y is 20. Dx is 2. Minus x, which is 15 times 3 over 2. So that is half 40 minus 45 over 2. Do the calculation, that will be 35 over 2. Okay. Part C. Part C saying what? Find the rate at which the angle between the ladder and the wall. This is will make an angle. You want to check how this angle is changing. Also, not take 7, we'll take 15. So this 15. To make the calculation easier. So now I need to relate the angle with x and y. How to relate the angle with x and y? I need tan. I have tan theta equal x over y. Okay. So that implies, and we have what? Now if you differentiate this respect to t, I have secant square theta times d theta over dt equal. And it differentiate this. You can make it x times 1 over y. So I have derivative of the first times the second. So 1 over y times dx over dt. Plus x derivative of the second, which is minus 1 over y squared dy over dt. Or you can do it question 2. No problem. Now I need to plug the numbers. I know x, I know y, I know dx over dt, I know dy over dt, I know all of these numbers. The remaining is this, secant square theta. How to find secant square? Secant, it will be this 25 over the adjacent, over y. So secant square is y is 25 over y. So we can plug it, we get everything. I know secant theta is 25 over y, and I know y is 20. So that will be 5 over 4. Okay, plug the numbers, we get what? D theta by dt equal square, that will be 16 over 25 times. I just make x, I just divide by secant square. Okay. This is y is 20, so it will be 1 over 20 times 2 minus x. X is what? 15. Y square is 20 square. And dy by dt, where is it? Minus 3 over 2. That will be minus 3 over 2. Okay. Do the calculations. You will get 5 over 32. Yeah, I will leave it. But this is the idea. You just plug the numbers and find it. Okay, now we'll move to the problems of the cars. Be careful about positive, negative, the rate of change. They say they have car A and car B. We have car A, and we have an intersection here. Car A is moving, headed to the intersection. Both are headed for intersection, going west. Car A is going west, and car B going north. This is car B. Okay. So call this X, call this Y, and I'm concerned about S, the rate of change of the distance between them as they are moving. Be careful here. He said car A is traveling west at 90. But if you notice, the distance, since I am heading to the intersection, the distance is negative. I mean, the rate of change is, the distance is decreasing. So the rate of change will be negative. And dy by dt, the same thing. The distance is going north, but the distance is decreasing. So dy by dt equal minus 100. Okay, what they want, they won't find ds by dt when x equals 60 and y equal 80. Okay, what I have, s square equal x square plus y square. Differentiate. First, when x equals 60, y equal 80, I can use this. S square will be 60 square plus 80 square. Very clear, s equal will be 100. So now substitute or differentiate this equation and just substitute. I have this, 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 I want this. Do the calculations. So cancel 2 with 2 with 2. Okay. If we do the calculation, you'll get what? S is 100, so I have 100. ds by dt equal x is what? 60 times minus 90. Y is 80 plus 80 times minus 100. So that means ds over dt, this is minus 5400. And this one minus 8,000 over 100. So that gives me what? Minus 134. And that will be the rate of change for the distance, which is kilometer per hour. The units are okay, so no need to worry about it. When there is a change in the units, we need to be careful. Now, two ships meet in the ocean. They meet in the ocean. They meet somewhere here. Ship A is steaming south, then one is going like this. This is A. The speed is 15. Call this X. This is ship A. So I have dx by dt equal 15. And ship B is steaming west. This is ship B. And this is called it Y. And they have dy by dt equal 20. Okay, what they want, you want the distance between them. The rate of change for this, which is called it S. So find ds by dt when after 2 hours, when t equal to 2 hours. And everything in hours, mile per hour, man. So we have no problems. Okay, what is the relation? S square equal x square plus y square. Okay, differentiate. I have 2s ds over dt equal to x dx over dt plus 2y dy over dt. I have this, I have this. That's it. I don't have x or y, but I can't find x and y. Why? Because it says after 2 hours. So after, if t equal 2, x will be what? It will be 15 times 2, since I have 15 speed. So this is after 2 hours, it will be 30. Y will be 20 times 2, which is 40 from here. So I have x and y. I can get s. So I have s square equal 30 square plus 40 square. Very clear, s will be 50. We know 30, 40, 50. Okay, plug the numbers. Now ds by dt will be what? X dx over dt plus y dy over dt over s. Do the calculations, you get what? Get a nice number. Let me do the calculation. X is 15. No, X is 30. Dx is 15. And Y is 40. And dy is 20. Over S, which is 50. That will be what? I have 450 plus 800 over 50. And that 1,500, 1,250 over 50. 125 over 5, and that's in 25. That's it. Two cars moving from the same point. They are moving from the same point. One is going east at a rate of A. This is dx by dt 80. And the other one is moving north. The other one is moving north. So let me write this thing here. You want the distance, the relative change of the distance between them. So call this y, and dy by dt equal 80, equal 60. Look, he's using per hour, huh? S. You want find ds over dt when t equal 30 minutes. What is 30 minutes? Per hour, which is half an hour. Okay. If we do the derivative, I need x and y, which I can get it from here using the time, like what we did. So I have x is 80 times half, which is 40, and y is 60 times half, which is 30. I know s squared equal x squared plus y squared implies that s equal 50. We did it. So now differentiate this. I have 2s over dt equal 2x dx over dt plus 2y dy over dt. I can cancel the 2. So I have ds over dt equal x dx over dt plus y dy over dt over s. Do the calculation. That will give me what? Nice number. Okay. Dx over dt is x is when x is what? 40 times 80 plus 30 times 60 over s, which is 50. The 30,200 plus 1,800 over 50. That will be 5,000 over 50, which give me 100. Okay. Yeah. There's a nice story. A piece of land is shaped like a right triangle. Okay. Two people start at the right angle. I have the right angle here, or the triangle, at the same time. They move at the same time and they walk at the same speed along the two different legs. I have one leg, right angle, triangle, another leg, triangle. So they move. This is x at the same time and the same speed. Okay, so I call this x, we call this x. What he wants, this will form a triangle. He said the rate of change of the triangle, this triangle, the rate of change of the triangle equal what? 4. What he wants dx, their speed, which is dx by dt, since they are moving x. Okay, if they are 5, when x equal 5, x is the same this way or that way. So what is the area? Very easy, half x squared. Half times the base times the height. That's it. Find the over dt. It will be x dx over dt. I have this, I have this, I can find this. So I have 4 equal 5 dx over dt. So dx over dt equal 4 over 5, which is 0.8. Okay. Two objects start moving from the same point. Okay. One travels south. Okay. 2 meters per second. This is the speed. Call it y. This is call it y. The other one traveled west. You want the distance, the difference in this distance. Call this y, call this x, call this s, like what we did before. So we have dy over dt equal to per second. Huh? He's using second in this case. And dx by dt equal 4. At what rate is the distance between objects increase? 5 seconds later. So I'm dealing with the same unit. Let's find, what is the question? dx over dt when t equal 5. I need this t equal 5. Because it gave me x will be 4 times 5, which is 20. And y is 10. That implies I have s square is x squared plus y squared, and that is 100 plus 200, which is 300. That implies s is what? 10 square root of 3. 10 square root of, no, wait a minute. This is, wait a minute. Why 100? From where it comes 100? X is 20, y equal 10. Yes, that 20 square plus 10 square. Yeah. That will be 400 plus 100, which is 500. So S will be 10 square root of 5, which is 100 times 5. 100 square root of 100 is 10. Okay, now we have everything. Differentiate this as usual. Cancel the 2. I don't need it. So I want ds by dt as usual. For S, what would be that? X, we said X is 20, and dx over dt is what, 4, and y is 10, this is 2 over 10 square root of 5. That will be 80 plus 10, 20, 100. So that will be 10 over square root of 5. Rationalize it. We're getting 10 square root of 5 over 5, which is 2 square root of 5. Okay. Two cars leave an intersection. One travels north. There is an intersection. One is traveling north. I'd call it Y. And the other one travels east. Call it X. So dy over dt. Positive, huh? Because the distance traveling increased. Huh? This, I'm talking about this increased as the time running. This is 30. And dx by dt equal 40. What they want, find, call this S. So find ds over dt when t equals 30 minutes. I'm working per hour, which is 30 minutes, which is half an hour. Because I need that. So y will be what? For x, let me do x first. X equal 40 times half, which is 20. And y is 30 times half, which is 15. So s square, I have the relation. S squared equal x squared plus y squared. At 20 and 15, that will give me what? So I have 15 square plus 20 square. And that gives me what? 15 square is what? 225 plus 400, which is 625. So S equal 25. Differentiate 2s ds by dt equal to x dx by dt plus 2y dy by dt. Cancel the 2. So ds by dt equal x dx over dt plus y dy dt over s over s. With the numbers, x is what? 20, and dx is 40. Y is what? 15, and dy is 30 over s, which is 25. We do the calculations. This is will be what? 800 plus 450 over 25. And that will give me what? 1,250 over 250, 25, which is 50. Okay. Two cars are moving still okay. The same idea. Actually, we have 1, 2, 3, 4. Yeah. I leave this. Okay. What is this one? Yeah, there's nothing there. This is correct. Two cars start moving from the same point. One travels south. I'm going south. Call it Y. And the other one travel west. Goes west. Sorry, this is we say east, but I'm doing it west. It will be the same. Huh? Yeah, just you reverse this. Nothing will be changed. So this is Y going north, and the other one going like this. But everything is the same. So this is minus. This is Y. This is X. Yeah. But yeah, everything is the same. So dy by dt. Here I will do it equal 30. And here I have the x by dt. Yeah, sorry about that. But the idea is the same. One travel north, south, the other one travel west. So I have dy by dt equal 30. And I have here x, the x over the 60. So I have this is S, and find ds by dt when t equal to. Same idea exactly. I have s square, or first I need to find x and y. X will be 60 times 2, which is 120, and y will be 30 times 2, which is 60. So s square will be x squared plus y squared, which is 14400 plus 3600. I don't know why they have this big numbers. 18,000, which is, if we do the calculation, is what? It will be 60 square root of 5. It has 100, and you can think of it 180 times 100. And 180 is what? It's 36 times 5. So you have 6 times 10 times square root. Okay, you can think of it this way. Now, calculations. Okay. This is S, I mean, huh? That implies S square root of 1000, which is 60 square root of 5. Now, differentiate to S ds by dt. The same idea exactly, dx over dt plus 2y dy over dt. That implies ds by dt equal x dx over dt plus y dy over dt over S. Do the calculation. X will be what? 120 times 60 plus y, which is 60 times 30 over S, which is 60 square root of 5. Okay. Do that, you will get what? Actually, I can cancel 60. So I have 150 over square root of 5 multiplied by square root of 5 over square root of 5. That will give me 150 over 5, which is 30 square root of 5, which is this one. Okay. Two cars start from the same point. One travels east. This is X. And the other one travel north. Okay. The other one travel north. So this is X, this is Y. And they have dx by dt equal 80. And dy by dt equal what? 60. And find ds over dt after t equals 30 minutes. And I'm working with the hours, which is half. So x will be 40 and y will be 30. That implies it's equal to 150. No need to waste time to do it again and again. It's very clear. Using s squared equal x squared plus y squared. This is s. Differentiate 2s ds over dt equal to x dx over dt plus 2y dy over dt. So ds by dt equal what? X dx over dt plus y dy over dt over s, and that give me what? X is what? X is 40, so it's 40 times 80 plus y, which is 30 times 60 over s, which is 50. We do that, you will get what? 5,000 over 50, that gives 100. Okay. These are the remaining. Now, not cars, persons. Ahmed starts walking north at speed 1.5. Ahmed starts walking north, call it y, and his speed is 1.5 minutes per second. Ali starts walking west at the speed of 2 meters per second. Ali starting, so well, x I have here. So I have dx by dt equal to, okay. At what rate is the distance between Ahmed and Ali increasing? I want this rate. S ds over dt when? When t equal 1 minute. Be careful. 1 minute means what? 1 minute. I'm working with seconds. It's 60 seconds. So x will be what? 2 times 60, 120. And y will be 60 times 3 over 2, which is 90. Use the same thing. S squared equal x squared plus y squared. Oh, that's a calculation. 2 more to go. X squared, that give me what? 12, 144, 0, 0, 90, and هو 81, 0, 0. Yeah, I think I will not miss time. Yes. So we'll find S. I will leave it for you. And then differentiate to S ds by dt equal to x dx by dt plus y dy to dy by dt. I'm getting ds by dt equals what? X dx over dt plus y dy over dt over s. I have x, I have this, I have this, I have this, I have this. Do the calculation. Okay. Yeah. Next one. Two people meet at the same point. One started walking north. Okay. Call it y. dy by dt equal to. And the other one started walking east. Don't do the same mistake. East, like this. This is x, so this is y. This is y. So I have dy over dt equal to. This is dx by dt equal 4. What they want? They want the distance between this, find ds by dt when t equal half an hour. Instead of saying 30 minutes, he gave it to you half an hour. Okay. Now we need to find x like what we did before. So x equal 4 times half, which is 2. And y is 2 times half, which is 1. So use the same thing. I have this is s. Okay, so I have s squared equal x squared plus y squared. That will be 4 plus 1, which is 5. So s equals square root of 5. So differentiate 2s ds by dt equal 2x dx by dt plus 2y dy by dt ds by dt equal x dx by dt plus y dy by dt over s. And that will be, what is x? X is 2. Yeah, these are nice numbers. 2 times 4. And what is y? Is 1. dy by dt is 2 over s, which is square root of 5. So it will be 10 over square root of 5. Rationalize. That will give me 2 square root of 5. Okay, I think this will be the last one for this group. Then I will have the one with the angles and then the shadow. Okay. Okay, at noon, I have ship A is 150 kilometer west of ship. Okay. Then this ship start sailing east, going in this direction. Going in this direction. Okay. And ship B is sailing north. Move X, this is move Y. So I have dy over dt, here is 25, and dx over dt, here is 35. He wants now the distance between them changing. Okay, be careful. Now from here, this will be the distance between them. So this is the triangle which I need to work out. This is S. All of this is 150. So this one is 150 minus X. So the relation which I have, S squared equal Y squared plus 150 minus X all squared. Okay. How fast is the distance traveling? What they want, find ds over dt at 4 p.m. They started at noon, 4 p.m. means when t equal what? Since I'm working with hours, when t equal 4. The speed per hour. I'm working t. What will be x? T equal 4. The speed is 35. X will be 35 times 4, and that will be 140. What will be y? 25 times 4, and that will be 100. Now, s square is a little bit different. That will be 100 square plus 150 minus 140, which is 10 square. That will be 10000 plus 100. That I can write it 10100. Or in other words, 101 times 100. So S will be 10 square root 101. That will be S. Differentiate this. I get what? Be careful now. 2S, the S over dt equal 2y. dy over dt. Now this is what? 150 minus x. Derivative of this, which is minus dx over dt. So ds by dt will be equal y dy over dt minus, I'm canceling 2, huh? No need to worry about 2, minus 150 minus x dy over dt, dx, I mean, dx over dt over s. which is equal to what? Y is what? Y is 100. dy by dt is 25. Okay, minus x 140, that will be 10. dx by dt, where is it? 35. Over this strange number, 10 square root 101. That will give me what? 10 times, I can take 10 as a common factor. Okay. Yeah. I can take 10 as a common factor. It will be 250 minus 35 over square root 101, which is 215 over square root 1. Yes. I think this will be enough for this part. And the remaining is only the angles, angle elevation and these things. And then the shadow problems. I need also to deal with the shadow problems and some miscellaneous things. Thank you.